Hi everyone, this is Babaiah, Assistant Professor of EC Department, MLR from Hyderabad. Transient or time response of a critically damped second order system for unit step input. Now we are going to learn the derivation or expression of how to solve the time response or transient response of critically damped second order system for unit step input. Just to move on to the today session overview, just to see the expression of time response of a critically damped second order system for unit step input. Now we are going to see this one, and also the output or graph of the respected critical damped second order system. Now we are going to see these 2 points, right? See, let's move on to here. Consider the second order closed loop unity feedback closed loop system. Here, see, this is the second order system. Cause of in denominator, s square is there, s into s square plus 2 zeta omega n. So just I'm going to consider g of s, here c of s, r of s, here h of s unity feedback is equals to 1. So for this, c of s divided, the transfer function of this circuit is c of s divided by r of s equals to g of s divided by 1 plus g of s. So here from this, already I explained for this, just to simply consider omega n square divided by s into s square, or else directly I am going to write this one, or in the form of s square plus 2 zeta omega n s, omega n s, right, omega zeta 2 zeta omega n s. For unity feedback system, the transfer function of that closed loop system is directly the denominator part is going to be add in the denominator, sorry, numerator part is directly adding with the denominator part. You will get this transfer function. This is the transfer function of closed loop system or second order system for unity feedback directly, or else you are going to solve this one equation also, g of s divided by 1 plus g of s. This is the g of s, just to substitute, where finally you are going to get this one. See here, these two are same, omega n square divided by s square plus 2 zeta omega n s plus omega n square, right? Next here, see, observe this equation. In denominator, maximum power of s is equals to what? 2. So the given system or transfer function is the second order system, or this system is the second order system. About transfer function of the system is second order system, because of in denominator term we have a maximum power of s is equals to 2. So that's why this system is the second order system. Now we are going to consider the standard form of closed loop transfer function. Standard form of closed loop transfer function of second order system or closed loop transfer function of second order system is this one, c of s divided by r of s equals to omega n square divided by s square plus 2 zeta omega n s plus omega n square. See here, now in this clause, zeta equals to 1 we are going to consider, means what? Critical damped or critically damped system. So for critical damped system, the zeta value or damping ratio is equals to what? 1, right? Equals to 1. Here substitute this zeta equals to 1, zeta equals to 1, substitute in c of s divided by r of s. Here zeta equals to 1, so omega n square c of s divided by r of s equals to omega n square divided by s square plus 2 zeta omega n. In place of zeta values 1, so 2 into 1 is 2 only, 2 omega n s plus omega n square. So finally omega n square divided by s plus omega n whole square, because of here a square plus b square plus 2ab. So here 2ab, so that's why a plus b whole square, that is s plus omega n whole square. Simply I am writing when input is unit step, or else for unit step input is nothing but r of t equals to 1. So r of t is equals to apply Laplace transform. Apply the Laplace transform for this input signal unit step. Laplace of r of t, Laplace of r of t, that is nothing but r of s. The Laplace of 1 is nothing but 1 by s. So that's why r of s is equals to what? R of s is equals to r of s equals to 1 by s. R of s equals to 1 by s. Here c of s equals to r of s into omega n square divided by s plus omega n whole square equals to 1 by s omega n square divided by s plus omega n. In place of r of s, just substitute 1 by s. 1 by s is there, omega n square divided by s plus omega n square whole square. This is omega n square divided by s into s plus omega n square whole square. This is the response of s domain. This is the equation of response of s domain, that is omega n square by s into s plus omega n whole square. Now I am going to, using the partial fraction or by partial fraction expansion, we can rewrite or we can write here c 1 by s omega n square divided by omega n square divided by this term. So for this, apply the or by partial fraction expansion, you are going to get 1 by a, or else a by s one term, and here s plus omega n square. This is also quadratic, so that's why here s plus omega n, two terms are there. S plus omega n, one term is there, again s plus omega n, one more term is there. So for that, b divided by value and b c divided by, so here b divided by s plus omega n whole square plus c divided by s plus omega n, s plus omega n. Here see ABC. Now we are going to calculate the a value, b value, c value. A is obtained, same method. A is obtained by multiplying the c of s. A is obtained by multiplying c of s with, in a denominator is what? S only. So s, and letting s equals to what? Substitute s equals to 0. Substitute s equals to 0. See, a equals to s is multiplied with c of s, letting s equals to 0. Here c of s is, we know, omega n square divided by s plus omega n whole square. Here s equals to 0, substitute in place of s equals to 0, omega n square divided by omega n square, that is equals to 1. So a equals to 1 you will get, right? Next, b is obtained by multiplying the c of s with the, here b denominator part is what? S plus omega n whole square. So multiply with the s plus omega n whole square, and letting s plus omega n whole square is equals to 0. Consider square and 0, if it is square and root get cancelled, here s plus omega n equals to 0 only. So s equals to what? Here from this, s equals to minus omega n, s equals to minus omega n. So substitute s equals to minus omega n for the calculation of b value, and multiply the s plus omega n whole square. Just we know s plus omega n whole square, already we know that c of s is nothing but what? Omega n square divided by s plus omega n whole square. Here s plus omega n whole square, this term both are the same, so this term is both are going to be get cancelled. Simply I am going to write here s plus omega n whole square into c of s is nothing but omega n square divided by s plus omega n whole square. This term both cancel. So letting s equals to what? Minus omega n. So just substitute minus omega in place of s. Here s minus omega n, just substitute here c of s. No terms are there right here. Simply s plus omega n square both are cancelled, so omega n square divided by some value. So here s equals to minus omega n. S equals to minus omega n. Just substitute here omega n square divided by S. Second, right, see, these two terms are going to be clear. So S value is equals to minus omega n, but here S term is not available. Here simply already here S is there, C of S equals to one more S is there. So right, sorry, here S plus omega n square into S, C of S is nothing but omega n square divided by S into S plus this term get cancelled. So 1 by S and R omega n square divided by S, that is here S equals to minus omega n. So here minus omega n plus omega n, 1 omega n get cancelled, minus only 1 omega n is there, so minus omega n. So that is B equals to minus omega n. You are going to get A equals to what? 1 you are going to get. Next, last, finally, here the next equation, C here, observe, C divided by S plus omega n, S plus omega n whole square into C of S. Here substitute S equals to omega n. This value also S equals to minus omega n, because of denominator S plus omega n equal to 0, S equals to minus omega n. And here also just differentiating this equation C, already this value is B value is calculated. So here S plus omega n whole square just into C of S, or here S plus omega n into C of S. Here C of S is nothing but omega n square divided by S into S plus omega n square. So omega n square, this both terms are same, equal d by ds of omega n square divided by S. Here S term is d by d of S is nothing but here S square. S square omega n square divided by S square. So S equals to minus omega n. Just to substitute minus omega n plus minus omega n. Here omega n is both are going to be minus 1, means here both are get cancelled. So here directly we are going to get the minus 1 simply by solving the differentiating this equation. Just simply you are going to get the minus 1. See here, A by S plus B by C by here 1, A equals to 1, B equals to what? Minus omega n. So minus C equals to what? Minus 1, minus 1 here. Okay now, minus 1 here, minus omega n whole square. So this is term going to be plus omega n square. So omega n square and omega n square get cancelled. So minus 1 you are going to get. So C equals to minus 1. C equals to minus 1. Here C equals to minus 1. 1 by S minus omega n minus 1. So the response in time domain. See here, differentiating this third term, because of it is involved in the second term also, S plus omega n square already here over, but here we are going to consider the S plus omega n for differentiating that equation or this term is by using the differentiating with respect to S plus omega n square into this term. Again this value is just to simply write. Now right here the response in time domain is 1 by S is 1, and here 1 by S inverse Laplace by here, just this is the response in S domain. Now we are going to convert the S domain into the time domain. So for time domain we are going to apply the inverse Laplace transform. Inverse Laplace transform to this response of that system C of S, response in time domain. Here 1 by S, here 1 by S minus omega n divided by S plus omega n square minus 1 by S plus omega n. So here C of t equals to 1 by S inverse Laplace is 1. Here omega n divided by S plus omega n square. See here, observe, omega n here S square, S plus omega n square, this term square is there. So 1 by S plus A, 1 by S plus A is nothing but e power of minus 80, and here square term is there, so that is the again this term is the t into e power of minus 80. Same here, t into e power of minus 80 in place of a is omega n, e power of minus omega n t. So already omega n is there, t into e power of minus omega n t minus e power of, so this term is comes under this formula 1 by s plus a, so e power of minus 80. So e power of minus 80, a equals to minus omega n, a equals to here minus omega n or else omega n. So omega n e power of minus 80. So that is the final answer of this critical damped under damped system is, sorry, critical damped second order system is C of t equals to 1 minus e power of minus omega n t of 1 plus omega n t of 1 plus omega n t. This is the second order closed loop system of or critical damped, sorry, because of here zeta equals to 1, right? So that's why this is the critical damped second order system response, and when we are going to apply the input as unit step, this is our response. See here, this is our response signal c of t in time domain. C of t equals to 1 minus e power of minus omega n t, here just 1 plus omega n t, 1 plus omega n t. The equation is same here, e power of minus omega n t, e power of minus both are there, so that's why just to common this term 1 plus like that. Just observe this one. The response of critically damped closed loop second order system for unit step is this one, 1 minus e power of minus omega n of t of 1 plus omega n t. For step input, step value a is multiplied, this equation a is multiplied, so just this one the step response. The step response this one and unit step, just this is the step unit step signal. Input signal is a unit step 0 to 1. Here the output response, here just completely in critical damped second order system, just observe that output is no oscillations, right? There is no oscillations. See here, the response of critically damped second order system is sketched as shown in the figure below, and observe that response has no oscillations, here, no oscillations, right? This is about the transient or time response of critical damped system for unit step input. When we are going to apply the unit step input, we are going to get 1 minus e power of minus omega n t of 1 plus omega n t is the response of critical damped second order system, and the graph of that second order or critical damped second order system is graph is observed, there is a no oscillation, in graph, just to be observed from that graph, right? This is about the response of critically damped second order system, or time or transient response of critically damped second order system for unit step input. I hope you understood every point. These are the systems based on the damping ratio, and also one more thing is there, over damped system also available. Like that same way you are going to use this equations standard form of closed loop transfer function, just to solve the last over damped system also. Same procedure for all the damped or else all the systems based on the damping ratio, that is undamped system, damped system, or underdamped system, and undamped system, and critically damped system. So all these are well learned for all the classes, right? So now one more is there, that is the overdamped system. You can also use the same equations, you can solve that one, you can practice that one also. Okay, from this the underdamped system is very important for you. Okay, all these are you should remember: critical damped, overdamped, and underdamped, and also undamped systems. Now this is the critical damped second order system response of unit step input. Okay, I hope you understood every point. I think you. And mm, next we are going to solve the sum, or else we are going to learn the sums time domain specification from the for the coming classes. Okay, thank you all.